Good morning. My name is Chirag Bansal and today we are going to learn about trees. So why do we use trees? Trees are suitable for hierarchical data. Suppose we want to store the files or want to store the hierarchy of employees, it is really suitable for that. It provides order, login, average time for search, insert and delete. It has no upper bound to the number of data that it can hold, unlike arrays. So let's look at some of the terminology used for trees. Node. Anything that stores data or conditions is called a node. So node of any tree contains some data and it contains references to the nodes connected to the particular node. For example, here we can see that node has some data, it has a reference to its parent and it has references to number of childs. Root. Root is the node from which all of the nodes branch. It has no parent. Child of a node. Nodes which are connected to the node moving away from the root. Parent of a node. Node connected to a node moving towards the root. Now let's look at the example. Here we have a tree. Now as we can see, all of the nodes branch from 1. Therefore 1 is called the root of the tree. These else or other nodes are just normal nodes. Child of a node. The node connected immediately to a particular node moving away from the root. As we can see, 6 is directly connected to 3, but it is moving away from the root. Thus, 6 is a child of 3. Similarly, the node directly connected to the node moving towards the root is called as parent. As 3 is directly connected to 6 and is moving towards the root, therefore 3 is the parent of 6. Leaf, a node with no children. Internal nodes, node with at least one node as child. Edge is a connection between two nodes. Path, sequence of node and edges between two nodes. Distance, number of edges in the shortest path between two nodes. Depth of a node, distance between root and the node. There is also a term called level, which is depth plus 1. Height of a node, number of edges in the longest path between node and a descendant leaf. Height of a tree, which is equal to the height of the root. Size of the tree is the number of nodes in a tree. Now let's look at this terminology using the example. Leaves. Leaves are nodes with no children. Therefore we can say 12, 13, 14, 10, 11, 5 and 2 are leaves. Rest all are internal nodes as they have at least one children. Now edge. Edge is the connection between any two nodes. Therefore this connection between 1 and 2 is termed to be an edge. Path. Path is the sequence of edges and nodes between the nodes between which we have to find the path. Distance between two nodes. Distance between two nodes is said to be the number of edges in the path from that node to the other node. For example, let's find the distance between 2 and 9. The distance between 2 and 9 here is 4 as we move from 2 to 1, 1 to 3, 3 to 6 and 6 to 9. We have 4 edges, thus the distance is 4. Depth of a node is said to be the distance from the root. For example, depth of 7 here is 2 as it has 2 edges between root and the node. The level of a node is said to be depth plus 1. Therefore, we can say this is level 1, this is level 2, this is level 3. Basically, it means how much further are we away from the root. Height of a node is said to be the number of edges in the longest path between node and a descendant leaf. For example, if we have node 9, the height of node 9 is 1 as it is 1 away from the leaf. Height of a tree is said to be the height of the root. Therefore, height of this tree, height, always remember that in height we see the longest path between the root and a descendant leaf. Here we can see that either 12, 13, 14 will suffice. Therefore, the height of the tree is 1, 2, 3, 4. Height of the tree is 4. The size of the tree is the number of elements and number of nodes in the tree. Therefore, the size here is 14.